Alright, hi, this is Petronack. This is Mastering Electronics Lab 7. So in this lab, we are measuring a diode and its current voltage relationship. So in this first circuit, we have a diode in series with a resistor, and we measure the voltage across the current, or the voltage source here, and the voltage across the resistor here, to determine that voltage drop across the transistor, and then we could determine the current that goes through it as well. And we did this across a number of different voltages through the voltage source from 0.1 to 5 volts. Alright, so for part B of this experiment, we have again a diode hooked up in series with a resistor, and we're putting through an alternating current source across the diode. And what happens here is that the diode resists current in the negative direction and the negative voltage, so we end up getting the negative portion of the AC signal cut off across the resistor. So you can see this kind of half shape here. Alright, so again in part B, now we've added a capacitor in parallel with the resistor. And so what effect this has is, again, we have the negative portion of the AC current cut off, but now we have something called a ripple signal that goes through here. So you can see that you have a sharp increase and then slower decrease, sharp increase, slower decrease with this AC current, and that's due to the capacitor kind of resisting change in voltage. Okay, so in part C of this assignment, we were looking at an active half-wave rectifier. So if you look over here, this is our circuit, so you'll notice there is a transistor here. We have a resistor coming off to the side that's attached to ground that's connected to the negative input. Our voltage signal is connected to the positive input, and we have a diode hooked up to the output, which is also connected to the line that the resistor was on here. And so what's happening essentially is that if you have a signal that is under the 0.7 volts voltage drop against the transistor, you just won't get a signal, but the op-amp can amplify that signal so that it's no longer an issue. So we can put things through like a 0.5 volt peak-to-peak signal and still get an output, which is right here. And you'll notice here at the 10 kilohertz signal, this is a 0.5 amplitude, you have a slew rate that you can see that's from our op-amp, so we'll be able to measure that.